Okay, so we're going to introduce a new equation now, and people find it very intimidating, but it's actually quite easy. Okay, work is equal to force on an object times the distance that force made it move times the cosine of the angle. Let's take that apart step by step. Okay, force. This is the force. Now, there could be many forces acting on an object. We're going to look at one force at a time. So distance. Distance is how far the object moved. Please note that if the object does not move in physics, no matter how hard you push, there is no work. So you can stand there and push and push and push and push against a wall, and you will have no work done. Cosine, we talked about cosine earlier this year. In this section, it's largely going to be something that you kind of put into your calculator. The angle is going to be the angle between the force we're focused on and the direction that the object is going. Okay, so in this situation, it would be 90 degrees. In this situation, if the force was going this way and the object was moving this way, we would have a force or an angle of 0 degrees. There are going to be some situations where the object's going to be moving like this, and I'm going to have maybe a 30-degree angle. Okay, what you would do is you'd put that in your calculator. Please make sure your calculator is in not in radians, but in degrees. That's important. Notice that when I sketched out which direction the object was going, I used a dotted line. I did that very lightly with my pencil because I don't want it to look like a force. You never want the direction that's going, even if you're keeping track of it, to look like a force. All right, we're going to do lots of examples of these so we can help you out. Okay, let's say we have a chinchilla. I actually cannot remember what a chinchilla looks like, but I remember holding one and it felt like a ball of fluff. So this is my chinchilla. So we're going to have this chinchilla. We're going to have somebody pushing the chinchilla to the right, and the chinchilla itself is going to go to the right. So let's say you're going to push little Chi here. We're going to push Chi to the right. Okay, so the direction that Chi is going to go is this way. I'm going to show it with a really light dot, like that. Okay, again, I'm using a dotted line because I don't want you to think that's a force. It's not a force, it's just the way Chi is going. Okay, so now let's talk about the force. Since you're pushing, let's focus on that force. Okay, so we have a force applied to the right. Let's go, and let's say that force applied is, let's say, 5 newtons. All right, and she is going to travel a distance of 2 meters. So we can say work is equal to force times distance times the cosine of the angle between them. In this situation, work is equal to, our force is 5. The distance that our little chinchilla is traveling is 2. Cosine of, and the angle between them, they're both pointing the same way. So the angle between them is 0. So work is equal to cosine of 0. You're going to put in your calculator, you're going to find that it's 1. So 5 times 2 times 1, the work is equal to 10 joules. That's one kind of situation. Now we're going to play with our same little chinchilla, but we're going to try something a little different. Okay, same chinchilla. It is being pushed in the same direction, and it's going this way. And we'd already talked about the force pushing it. Let's look at another force that would be acting on our chinchilla. All right, a really common one, our force of gravity. How much work is the force of gravity doing? Let's go to our equation. Work is equal to FD cosine of theta. And let's say that our chinchilla has a weight or a force of gravity of, let's say, 7 newtons. Okay, and our little chinchilla is still moving forward 2 meters. So we're focused just on force of gravity. So we're doing kind of the work one force at a time. We already did the force applied in the last slide. Now we're going to be doing this one. So our force of gravity is 7. The distance the chinchilla is going is 2. Notice that I'm still using the same distance, even though the force of gravity really isn't helping it do that motion. The cosine of the angle between them. All right, let's look. The chinchilla is going this way, and force of gravity is down, so they are at a right angle. Force of gravity is this way, chinchilla is going that way, that's a right angle, so cosine of 90 degrees. If you put that in your calculator, you're going to find cosine of 90 is 0. So work is equal to 7 times 2 times 0. So actually, no work was done by the force of gravity. That makes sense. Even though you had a force of gravity acting on the chinchilla, it didn't help speed the chinchilla up, and it didn't change its potential energy. So it did no work for the chinchilla. It didn't change its kinetic, and it didn't change its potential. That makes sense. Okay, so we have the same chinchilla and the same other forces are acting on it. So far we've talked about the force applied pushing it this way and the force of gravity pushing it down. But we're not going to really worry about those two. We're just going to focus on our force of friction now, and we're going to figure out how much work is the force of friction doing. And let's say friction was applying, let's say we were doing, let's say 1 Newton of friction here. Okay, so what does that mean in terms of work? So we go back to our same equation. Work from friction is equal to FD cosine the angle between them. So work from friction is equal to, the force of friction is 1, the distance that the chinchilla is moving is 2, and the cosine of the angle between them. Well, let's look. The chinchilla is moving this way, and the force applied to it is this way. Okay, so it's moving this way, force applied this way. The angle between them is 180 degrees. So the work is equal to, cosine of 180. If you put that in your calculator, you're going to find this is -1. So 1 times 2 times -1. Work is equal to -2 joules. That's from friction. Okay, so far we've done force applied, we've done our force of friction, which was smaller, we did our force of gravity. So our last one we're going to look at here is our force normal. Okay, so let's do how much work the force normal would cause, okay? FD cosine of theta. So work from the normal force, or force normal, is equal to, all right, let's say, well, if you remember from before, our force of gravity was 7 newtons. So this was 7 newtons, which means our normal force has got to be the same, because the little chia pet chinchilla is not floating and it's not sinking down into the ground. So we're going to have a normal force of 7 newtons. The chinchilla is still moving 2 forward, okay, and it's moving in this direction. So what is the angle between them? If you look, it is a 90-degree angle. So here's your normal force. The chinchilla is going this way, so the angle between them is 90 degrees. So cosine of 90 degrees. If you put that into your calculator, you're going to see that the cosine of 90 degrees is actually 0. So the work from the normal force is equal to 0 joules. In other words, the normal force is not changing the kinetic energy, not changing the potential. It's kind of useless in the situation in terms of changing the chinchilla's life at all. Then let's look at both, like all of this together. So what is the total work then on the chinchilla? Well, the force applied was 10 joules of work were done from the force applied, minus force of friction did 2 joules, and it's minus because that was a negative value, equals, and our total work is, oh, I'm being messy here, 8 joules on our little chinchilla here. So that's kind of how you approach the idea here and how you deal with that cosine.